Welcome, everybody. Rowena Gates is a principal at ENG3 Corporation. She helped launch ENG's NanoVi technology and currently oversees business development for its use in health, wellness, and performance. Rowena has been a serial entrepreneur since 1995 when she co-founded one of the earliest companies to offer an internet-based solution to the logistics industry. Rowena received her PhD at the University of Washington for her work in international strategic alliances and regional economic development. While her collaborative approach remains, her focus has shifted from the economic well-being of regions to the health and wellness of individuals. Welcome, Rowena.
Thank you. Hi, thank you everybody for being here. I'm assuming you can hear me and we're all good to go? Yeah, so that's a little bit about me and my background. We've been doing ENG3 and working with NanoVi for a number of years, and we have a pretty broad history of its use. But before we get into any of that, I was going to give a little bit of an overview of kind of the protein functions, what we're doing. I wanted to talk a bit about proteins, what they are, how they get built, and the functions in the body. And then where protein folding comes in and why that's so important for all of us, for all these areas. And so if we look at proteins, they're a chain of amino acids that have to fold into a three-dimensional shape. And they can be almost any length, and there's a huge amount of variety in them. There's about 1 million at the end of the day that can be formed in the body. That's not a number they know exactly. And they can identify and name about 50,000 or somewhere in that range. So they can't even name most of them, and let alone to understand all the things that they're doing in there. Really important for us is the folded shape of the protein is what determines its function. So predicting the folded shape is important because then they know what the protein's doing. And that folding is the part we really focus on. But before we get there, this is an interaction that gives you an idea of a small group of proteins and some of the interactions. Now, I should have mentioned that, or you maybe picked it up from my bio, I'm not a scientist by training. And we're fortunate because we have Hans Eng here, so any questions you have, he's the engineer behind it. We've got him right here live. The first Biohacking Conference that he's been available to all of you. And but I don't have to be a scientist to look at that and say, oh, that looks complicated. And that's just a few of them. And there's all these interactions that take place that we really don't understand. And that's why sometimes things can go wrong. And sometimes we call those, unintended consequences or, drug interactions and so on. And so these proteins are playing a huge role in the body. And we often focus on DNA. And we think, oh, the DNA is important. It is. We want to protect it, keep it healthy. Of course we do. But the DNA only has one purpose, and that is to be the blueprint for the protein. And so basically, as much as your DNA does everything, proteins are doing everything. They make up most of your body. The most abundant one is collagen. And they do all the work, your immune system, your digestive system, the movement of my hand, all of that is a protein function. There's pretty much nothing that's not involving proteins in your body, triggering reactions. And so you can't really overstate the importance of proteins. And proteomics is just something that's really coming into the forefront of medical research, in part because we have the tools to get a better grasp on it and to do more about it. The proteins and protein interactions have been known for a long time. It's just that it's really sort of evolved to the point where we can see what's going on better. And to give you an idea of all the things they do, if we look at the groups of proteins that exist, this is just a common classification. You could probably slice and dice all these different proteins in many different ways. This is a really standard one, but I mentioned the structural, the collagen and so on, transportation, receptors, storage, all the signaling proteins, and then enzymes, which any of the enzymes are catalyzing reactions. And the model you see on your right side is catalase. And so that's a really important catalyzing enzyme in the body. And then they regulate your genes. There's motor proteins and special purpose proteins. There's probably an endless number of special purpose proteins. So that kind of gives you an idea of how broadly they are covering the whole human system and everything that goes on inside it. I wanted to talk a little bit about how we get them. I mentioned the DNA. Its role is to be the blueprint for the proteins. And something we hear more about lately is mRNA. And so think of your DNA as like an architectural drawing, some really beautiful blueprint for a building that's just one of a kind, hand drawn. You wouldn't put that out onto the factory floor, right? So the DNA is sequestered in the nucleus of the cell where it's kind of protected and safe in there, and it's not likely, can be damaged, but it's not as likely to be damaged by oxidative damage and free radicals. But to get it out to the factory floor and actually build the protein, you need to make a copy of it, which is the ones you'd see, the big messy drawings you see out on the floor. And that's transcription. So they create the mRNA, messenger RNA creates the copy of it. And it's interesting because you don't have that many DNA, but you have a lot of proteins. And so it's during transcription or later during translation that you can vary what you're building on the fly. And so transcription could involve a few edits depending on what's going on in the system and what's needed. So other proteins can come back and kind of modify the process while it's being built. And so if you think about a factory that you're building a product and the product can then come back and help retool the factory to make something else, you get this really complicated process of the proteins being built. But you have many varieties and variations, and so that you have many more proteins than you have DNA. And then the same thing is the translation. Your ribosomes are going to make this thing. And during those processes, you can also have modifications or damage that makes it come out not quite right. And this is where we get excited about epigenetics, because that's an area where you can influence what's going on given the DNA that you're dealt. And most of us have good enough DNA to be pretty healthy. We may have to make some tweaks, but we can often do those epigenetically. And so that's a lot of what we do in biohacking, is we're trying to, keep things on the rails and make up for deficiencies potentially. And so then you end up with the protein, and this is just the primary shape of a protein. It's a chain of amino acids. And there are, say, 20 amino acids. Your body makes about half of them, and the other half are you need to eat. And those are called essential amino acids because it's essential that you get them into the system. And that's where you see all of these supplements, right? You've got proteins and enzymes and peptides and all these different things that you can take to make sure you have the right building blocks in the system. So each of those amino acids is a building block for whichever proteins must be made. And these amino acids can be strung together in any order, in any number, and they have to be perfectly done to get a functioning protein. And so if we go back a little bit, say, to collagen, there's over 1,400 amino acids in collagen that all have to be, the right number, the right order, and perfectly come together in a folded shape in order for collagen to work. So it's really, pretty much a miracle what's going on in there. And then there's others like insulin is a really common, it's a hormone that is a protein, and it has 51 amino acids. And so there's a huge variation. It's not uncommon that there's 40 or 50, but there can also be a great number of them in the system. And they all have to behave correctly and fold correctly in order to work. The next thing here is to move from the protein that you eat into a protein that works in your body. So this is kind of back to you're taking a good diet. If you have a great healthy diet, you don't even need to supplement it. It's all good. But that's hard to come by these days. And so you have the protein that you're eating. It doesn't just get packed onto a muscle. Like I ate collagen and now the collagen's showing up here. It gets shredded by the system. It gets broken down into subunits, polypeptide chains, and then individual amino acids. So now you've just got the right building blocks to create the proteins that you need. And then the first thing is you get the right number of proteins in the right order of the right type. And then you have the primary structure of a protein, and that's the backbone for the protein. It has side chains that are going to help it later when it needs to fold. These side chains are terribly important to that process. And then the first things, a secondary protein can be where it shapes into either an alpha helix or a beta sheet. And that's another interesting area with for example, beta sheets or beta sheets, if they don't fold to the next level, can stick together like pieces of paper in a stack. So one can kind of stick onto the next instead of moving freely. And when that happens, it can form plaques. And so if things go wrong in this stage, you get things like tangles and plaques that are implicated in neurodegenerative diseases. So you really want these things to not misfold, not stick, not belong together. And also, once they start sticking together, then that disrupts more and more proteins. So it's sort of this downward spiral. We want to avoid those. And then have it fold correctly into what's called a tertiary shape. And that's a polypeptide chain that may be a whole protein. Or there might be several polypeptide chains that come together to form a protein that's a bigger molecule. And in this case, that would be a pretty decent approximation of a hemoglobin molecule where 4 polypeptide chains come together and they form that one hemoglobin molecule. And so it gets really, it's pretty complicated in there. And throughout this whole process, the amino acids are coming together. They have to fold into a three-dimensional shape. Where do they get the energy for that? How do they actually, just magically fold? They get it from the water that they're immersed in. And every protein is immersed in water, in or not necessarily inside your cell. And that's where the energy for folding comes from. And so the water has to be in a specific state in order to support that protein folding process. And so that's an important piece for what I'll talk about later. And so if we go here, we've got the chain of amino acids, and then the little dots on the side of that are meant to represent side chains. And it's the side chains that help twist this thing around into the correct chain shape. And there can be, charges or bonding, various types of bonding that does that. And in this case, you're just getting a globby protein, and there's all kinds of different classes, like globular proteins are actually a class of proteins. One that you might have seen more is an antibody. And antibodies are actually 4 chains of polypeptides, but they come together and they form this Y shape. And if you think about models that you've seen lately where they're showing the antibodies and so on, they usually take this little Y shape. And that's because a lot of the antibody proteins take that form. And so they use that in the models that you would have seen related to the current, challenges we've had for the last 2 years. And so then if we look at this, the way we look at this is that you've got an unfolded protein that's like this. So we have push puppets for you because everybody needs one. And this is a protein that's not functional. It's a chain of amino acids, but it's not functional. until the bonding comes into place and you have to have the correct bonding, then it operates, and it's a real live protein that can go off and function. And so we brought these for you as a reminder because you may have children at home, and you can take as many as you like. Haley is here with me, and she's at the back, and she's got a bag of these. So you can go, and then on here there's also a QR code if you want to learn more. And so we can, but anyhow, that's what we use the push puppets for, and it's a really, it's the best example we have of what's going on. And so the importance of this, it's hard to overstate this, but I'm going to try to give you an example. First of all, that folded shape of the protein, knowing that, predicts its function. A huge number, they say around 80% of pharmaceuticals are based on the folded shape of the protein. They want to know what that is because once they know that, they can predict what it does, and then they can intervene and they can add or subtract or block a receptor or whatever they can do. They're trying to manipulate those proteins to our advantage or somebody's advantage. And so that's how important it is. And that prediction has gotten a lot better because of artificial intelligence, not surprisingly. And so this is what we see as the last year's breakthrough of the year. This is announced every year in December. And last year's was the breakthrough of the year. The most important scientific breakthrough was the advances in artificial intelligence to predict the folded shape of proteins. The year before that, I love this quote where they started to get really good at artificial intelligence and it was clearly coming online. This will change medicine, it will change research, it will change bioengineering, it will change everything. And so that sort of gives you a flavor of where medicine is going with this. It's certainly a frontier in medical research. And I think we're going to see some very good breakthroughs that are to, human advantage that come out of this. Let me give you one example of what the kind of things that can be tweaked. So this is a hemoglobin protein. It's got 4 chains that are each over 140 amino acids, 4 polypeptide chains. They're all in the correct order. All the bonds are correct, and you have a properly folded hemoglobin protein, which most of us have running through our blood constantly. We love that. However, what happens if you get close to that? You've got 574 amino acids. They're all in the correct order. And actually, only one of them has side chains that are not correct. And that makes it bond with a second amino acid, so only 2 out of the 574, and you get a misfolded protein. And that's a sickle cell, and it's that crescent shape. And this is a really unfortunate, understudied disease. In this case, it's genetic, but these issues don't have to be genetic. And so this is the kind of thing that goes wrong with misfolding. And so we don't want that. And there's endless things to discuss. It's just that all of us can identify with hemoglobin. And some of them are genetic, so they're DNA, and some of them are not. And many of them are not, and they're almost self-inflicted in some cases because it's oxidative stress and oxidative damage that cause proteins to not fold correctly or misfold or unfold, and things can go sideways. And that's why so many diseases are age-related diseases. All these chronic illnesses are age-related because there's been enough time for the oxidative stress to build up. And it builds up over time, and then you have the issue showing up in later years. We love biohacking because so many people that are younger are preventing the buildup of damage rather than waiting until there's a train wreck and then trying to recover it later, which is sort of a more conventional model, it seems. So with oxidation, the oxygen irony is that any oxygen metabolism creates oxidation, which is not good for you. However, if you don't have oxygen metabolism, you're dead. And so you need both, and the key is to repair that damage as fast as you can. Proteins are often damaged, and they often have to fix themselves because they're very handy in the cell. A cell, they can't really count them, but there's estimates, 6, 8, 10,000 proteins in one cell, and a cell is a very small place. So proteins are the most abundant component, and they're super handy for a free radical to attack and damage. And the antioxidants, everybody, most of us try to make sure we eat good, healthy diets and have antioxidants in our systems. Absolutely essential. Our antioxidant defense protects us. However, it will not repair damage after it's done. It's just a protection layer. And so it's the proteins that have to then go back in and repair things. And proteins they'll repair the most critical things first. There's sort of this hierarchy in there that you really want to make sure the repair happens. One of those is DNA. That's a priority to keep the DNA healthy. However, if we build up a lot of oxidative damage, then the body just doesn't keep up, and we kind of call it aging. So that's a critical aspect of it, and that's why if you go back to the epigenetics, if you can keep things from being damaged, you're going to end up so much healthier at the end of the day just by having stuff never go off the rails. And so that's where proteins come in and do all the repair. I'm changing gears, by the way. I wanted to say that on the other slide. But so how can you how can we help protect ourselves, reduce oxidative stress damage, increase our chances of staying healthy? And this is the technology that our company represents. And Hans, do you mind standing up? Because this is the man. Actually, you have to come over here to be on camera. This inside these lines, then you're on camera. Okay, everybody. Hans Eng is my partner, and he is the engineer behind the science of this. He's a German engineer. It's perfect. The product's built in the US, so that's also really good because it's handy. And he's available for any in-depth question. Just, once you get him started, you'll get endless information from him. So the device helps repair and regenerate, and it does it by influencing the cellular water. And that's the key point. All we do with this device is we kind of come in underneath, get the water into an energy state that's more favorable for protein folding, and then your body takes over. It does all the rest. It knows what to do. It doesn't override anything, and there's no interactions because there's no way you can have, some unintended consequence when you simply support the body to do what it already knows to do. And so instead of having Hans come up here with the push puppets or me wave my arms, I'm going to run a video that will walk you through. It's only 3 minutes, and it walks you through the technology, and it's the easiest way to just kind of see what's going on. It's available at our website.
A great example of Ing3's supporting materials is this animated video on how NanoVi works. It is found at our website, ing3corp.com.
Energy for life. More than 99% of our body's molecules are water. The DNA and proteins, which are the second most abundant compound, are embedded in this water. Hundreds of thousands of different proteins execute every process in your body. Tens of thousands are found in each cell. Folded proteins are essential for cellular activity that keeps us vital, healthy, and alive. Unfortunately, folded proteins and the DNA are constantly damaged by free radicals during oxidative stress. When unfolded, they lose their function. This reduces cellular activity. The results are loss of performance, aging, and in a worst-case scenario, chronic disease. Fortunately, repair and regeneration are possible and occur when proteins fold and refold. Always, along with free radicals, signaling molecules known as excited or activated oxygen are generated and emit a specific electromagnetic energy. This energy is absorbed and transferred by water, forming layers of ordered water on its contact surfaces. These layers are also called exclusion zone or EZ water. It is more densely packed and has a higher energy state. They provide the energy required for proteins to fold. When enough layers surround a protein, the folding happens spontaneously and the protein starts functioning. This essential biological process can now be assisted by the patented NanoVi technology. In NanoVi devices, the same signal is emitted into water droplets in an airstream, leading to the formation of ordered water vapor. Universities and test facilities verified the signal's quality and intensity as bioidentical, and that the vapor contains EZ water. Inhaling NanoVi's ordered water vapor affects the entire body. Thanks to the unique properties of water, NanoVi's specific energy is transferred from vapor droplets to cells and ultimately to proteins. Here, NanoVi provides much-needed energy to the protein folding process. Not only DNA molecules repair faster, but all cellular activities improve with proper protein function. By assisting their folding, functions are not lost, but are reinstalled. Therefore, NanoVi is used to address chronic disorders, to slow cellular aging, and to recover faster from mental or physical performance. Now, you can enhance vitality by boosting regeneration at the cellular level. NanoVi provides more energy for life.
So these are some of the institutions they mentioned that it's been studied and verified. Some of the studies we have are on the technology itself that is actually doing what we believe it's doing, and we can prove that. And then other institutes have measured the impact on the body. And so these are some of the institutes that have studied it, a lot of university research behind it. And one of the things we're most excited about is an article that was published earlier this year that looked at the impact on proteins. And in this case, there were 3 proteins, alkaline peroxidase, which is good for it helps with gut health, bone density, and neurogenesis. So it's pretty important for keeping your brain healthy. Peroxidase, which counteracts the free radical peroxide. And then catalase, which is the enzyme that initiates the decomposition of hydrogen peroxide into oxygen that you need for your energy and water that's harmless. So you really want that to work well. And this is that molecule I mentioned earlier, the catalase model. And one of the results out of this study was that with the single session, it was 18% improvement in that decomposition of hydrogen peroxide into energy that you use and into harmless water. So it was a pretty significant impact. This study was really involved, and I promise I won't go into all the details. We can certainly get it out to you if you're interested. I'm only going to give you a couple examples from the study because it would go on for a long time. And this is one of them that's showing basically what they did. Their purpose was to show if NanoVi is effective for the repair of damaged proteins. So they always damaged the proteins. They did it in 3 different ways: by oxidation, by heat, or by chemicals. And all of the different proteins were damaged. If you look at this graph, the red line is the damaged control. So nothing happened to that. The yellow line is when they were treated prior to damage with a sham device. So the device is turned off inside, the humid airflow, everything else is exactly the same. And the blue line is when they were treated after damage, but with a sham device. And then the 2 lines up top are active NanoVi devices. The most effective one in this case was treating after, and that's the green line. But also, very interesting, treating before was also effective. So these researchers concluded that it is not only restorative, that it's also protective. And then this is just the one example of oxidation. There's a 42% improvement over the controls when the NanoVi device was active, and in that case used after. If we go over to when they're damaged by heat, this is also interesting. For this protein, pre-treatment didn't help, because you see the purple line is down there with the controls. It's just not significant, or not significant enough. However, when you treat after, and it's a heat damage alkaline phosphatase protein, then you get a dramatic improvement, 32% better than if you use the damaged control or the sham device. I'm sorry, those percentages are over sham device. And so this is a huge step up. We also, the chemically deactivated, I don't have another slide to show you that, but when it was chemically deactivated, it was 28% improvement over a sham device. And they're all, of course, statistically significant. In fact, everything I show you, I'll just say up front, is all statistically significant at least a 0.05 level, and often higher than that. This is the only study that I'll show you today that was not done right before and after. So when you use this device, we can show that one treatment is beneficial. Maybe should use it every day, but one treatment is beneficial. This is the exception. This was done in an Olympic training center, and they were doing a week-long endurance athletes. And it's a small study, only 6 of them. And they, in each case, the interval training they did with the NanoVi device incorporated daily lowered their double-strand DNA breaks. And so double-strand breaks are the very hardest ones to fix. They're the most dangerous kind of DNA damage, because one side of the double helix can't just replicate off the other side of the double helix when both strands are broken. And so it's very involved testing to measure these double breaks. But this is the result. There's an average of around 25%, range from about 14 to 35% improvement. So if you're that 35% athlete, you really want to be changing your regime a little bit, because that's a lot of DNA damage to not be, correcting on the fly. And so then we also looked at, this is a before and after study. This is only with treatment only before an all-out exertion test. So they did exercise until either the doctor stops the test or they kind of collapse off the treadmill. And so they did a half session prior to that all-out exertion, and the level was 17% less lactate measured at time points going out. And you can see they measured, all the bars on the right side, they measured at 5 different time points. And you can see it sort of, as it covers. And the most dramatic was right after the all-out exertion test. That was the 17% improvement over the sham device. And again, the device is the double-blind placebo-controlled, so neither the researchers or the subjects knew which was a real device and which wasn't. And if you remember the picture of the device, it just looks the same from the outside. It's great. It's better than the sugar pill, because there's no way anybody could tell what's the placebo in this case. And then this is also looking at your immune response, and they're using a white blood cell, these different components, as markers for inflammation. That inflammatory response is what you want when it's acute inflammation. That's your immune system kicking in to solve things. What you don't want is chronic inflammation. And so this is only studying the good inflammation, and these ranged from 10 to 17% improvement in these markers in that immune response for athletes that were stressed. And so that's something we see a lot of, where athletes recover faster, and they can tell. People that are trained, they can notice that difference relatively easily. And then this is just an example of a brain. And this was an executive who scanned before and after a 15-minute session on the device. And it was a stressful, highly focused, concentrated time. And so what you see here is actually, a lot of people think it's inflammation because it's red. It's not. It's inappropriate brain activity. And so what happens, we notice our inappropriate brain activity as brain fog, decision fatigue, lack of clarity, sometimes exhaustion. Those are all more likely what we will notice. And you can see the reduction, like visually, you can see the reduction in that kind of brain fog state. And so that's another important point is if you're really concentrating for, I guess it's now about 2 hours, it's about the same as running a marathon because you're still burning a ton of oxygen in your brain and you have oxidative damage where you're burning the oxygen. And so you don't have to be a physical athlete to have oxidative damage. So you obviously want to repair the damage as you go. And the brain is a place where people are more and more focused on making sure they keep that healthy. So this is the areas of use for the NanoVi device. And let me start on the right side instead of the left side because for accelerating recovery, we have a long history of accelerating recovery, a long history with chronic diseases. And we don't talk about them, but you could ask us individually or whatever. That accelerating recovery is huge for any chronic disease. They're all related to oxidative stress damage. If you can improve your oxidative response, you can assist those diseases. And then the other two areas I want to talk more about because it really fits better into the biohacking space. And healthy aging or maintaining wellness and improving performance is really the agenda of this conference. And so I thought about this, like how do you get across the point of healthy aging and performance, and I mean mental and physical performance. And there's one area that I'm going to talk about because I think it's almost the pinnacle of physical and mental performance. And in this amazing case, it also involves aging. And I think that's a really nice combination. And so I could go on and on about, we have professional athletes in baseball and football and basketball and hockey and soccer. And, we've got famous people that I probably don't want to name drop here and all of that. And I could give you all those names, but I'm just going to give you an example that's kind of extreme and it's close to home because it involves both performance and aging. So this is Janine Schaffner. Now you can tell she's not a youngster. She is late 50s and she's endurance race car driving. On Sunday, they were placed second in their class at the Red Bull Ring, which is a Formula One circuit in Austria. And she performs against people that are, 22 and 29 and so on. It's often a young person's sport because it's so demanding. Everybody knows it's going to be mentally demanding, but people don't appreciate how physically demanding it is. The cars aren't easy to drive, and there's so much going on. And her quote is, it helps her, stay on the track, sharp mind, sharp body. And what's really cool about these people is you can see on her left sleeve, you can see the E, and that's the first part of our logo. And these guys appreciate our device so much that they keep it on their jacket and on their car, which is really kind of an honor because the performance at this age, like most of us think healthy aging, I'm going to go play tennis, I'll go skiing, And these guys started driving about 6 years ago. And they learned to drive. They were pilots. They'd done all this. And she's done, I think it's 300 base jumps and thousands of skydives. Like she's not like most of us. She's not at all like any of us, actually. I mean, people just don't go base jumping, And so anyway, it's really impressive to see people perform at this level when they're not 22, like their competition. And this is their car. And you can see the little Eng3 on the fender. Can everybody see that? You gotta love that. And I put it in our logo at the bottom so you could compare. But we would not have the budget to replace one headlight on this car. And we just so appreciate that they keep us on the car because they appreciate what we're doing. And so in many cases, it's an hour of endurance racing. Janine has done 4 hours on her own, but that's very rare. And that was on what's often considered the most dangerous track in the world. And I have no idea how she did it, but she said she'll never do it again. And she's the only woman to have ever done it. They're making a life-important decision every 2 to 3 seconds. And so that concentration and focus are huge. It's physically demanding, as I mentioned, and they really do compete against people that are so much younger than they are. It's just stunning. They could be grandchildren in some cases. And they've grown up their whole lives racing. You know, they didn't start. One of the team members here started, he was already in his 60s when he started, and he's not racing this year because you can see it's sponsored by Axiom Space, and they are the space company, and he's piloting a mission to the International Space Station that's supposed to launch May 1st, so he spent a lot of time training with NASA to be able to do that. And it's yet to be seen how that all plays out because those things can always slide, but he promised to call us from the International Space Station. So. And so that's an example of like the whole spectrum of aging, performance, mental performance. And I want to give you one example. This is a voiceover of John Schaffner, the guy who's going to space. And it's a bit quiet, so I hope you'll be able to hear it. And watch for I think it's a Porsche that comes out of the rain on the right. And it just gives you that little hint of what it's like to be in one of these cars. This is the Nürburgring, the dangerous track, and they often have rain. And so it's so funny in this other series with the Formula One track, these guys are praying for rain because they can drive in rain way better than a lot of the other drivers. So they're doing a rain dance, you know. I'm like, oh, I don't think that sounds good. So here we go. Are we ready?
NanoVi makes me competitive, and I am competitive against the younger drivers. You know, still have some work to do, but without the NanoVi, I'd be miles behind. It's for me an imperative.
And so that's a little nod to us. And so I'm going to just sum up. It's protective and regenerative, this device. It's used for performance and to maintain health, wellness. And it's used for recovery. And that's recovery both from your own physical or mental endurance, or from if illnesses, it's also used for that. It's scientifically validated. Happy to send those studies. Haley's in the back. She's my colleague, and she can make sure we have your badge scanned and send them out to you if you're interested. And don't forget your push puppets. Nobody gets to leave without it. And then it's really easy to implement. It's just like pushing a little blue arrow to get it started. So if it's going into a center, people can self-serve. It's just so easy to add. And I want to mention that at the very beginning, that came up, my PhD was in strategic alliances. I've always worked on collaboration. And we really see our role as, we collaborate in helping people in terms of this complements other things they're doing. If they're doing hyperbarics, perfect. Hyperbarics, of course, has oxidative issues, so do NanoVi as well. And in biohacking, there's nothing that conflicts with it. There's no contention here. They're all supporting each other, and we really love that. So it stacks with just about everything. We have a lot of use with hyperbarics cryo, which is kicking in cold and heat shock proteins, and so you want them to fold nicely once you do that. And red light, PEMF, compression, all those things it's used in combination with. And we like it that way. If you wanted to learn more, this wasn't enough. And Hans, you don't catch him. There's any of these podcasts, and there's others as well, but these are places that you could go and find a conversation about NanoVi, either with Hans or myself, or in some cases both. And you can learn more from that as well. So I just want to remind you about the push puppets one more time. I know I'm selling push puppets here. And questions?
Yeah, the water that's pictured there, is that specific? Because I'm a little bit of a water freak.
Yeah.
So the water, of course.
It has to be very clean.
Right.
We don't want any surfaces in the water because we want the ordered water to form on the proteins, or on the water droplets, not on surfaces inside the water. Right. And so very clean water is what we're using here.
What would be the best preparation? Because I know I'm very detailed in water preparation. So what would be the best preparation if one were to have the system and use it on a daily basis?
I'm going to say you would know best.
Yeah.
Because most people that use this use distilled water in it. Because that way they just can buy it, they know it, and so on.
And from the distilled water, the machine would do its magic and deliver what it needs.
Correct. So we want it clean, we don't want anything deposited inside, and so on.
Got it.
Anybody else? Did I run out of time?
Change the water every day?
In a clinic, yes. At home, it's usually every few days or a week, about every 10 hours of use. And it depends on air quality. But if you have crummy air quality, change it more. Yeah. Hi. Oh, thank you, everybody.